Oh, hello. Man, it's really windy out there. Really got my hair. But anyways, today we're going to talk about high and low pressure. The air in the atmosphere moves from areas of high to low pressure. That's what causes wind. When it goes from the high to the low, okay, that causes wind. That's what really got my hair. Man, that was a really strong wind. Anyways, the change in pressure causes wind or advection. That's another word for wind is advection. Okay, you might hear that. That's why we want to give that to you so that you understand that. Now, on an isobar map, a map that's showing the isobars, the lines of equal barometric pressure, okay, you can see that if these are the isobars, the blue lines that are drawn here, okay, where the lines are closer together, that's a steeper gradient, okay? That's why I put it right here, steep pressure gradient. Okay, because the lines are really close. That means it's changing very rapidly. That causes wind. Okay, whenever we're moving from areas of high pressure to low pressure or low pressure to high pressure, it doesn't matter. But the winds blow from the high into the low. But only that change, the faster that pressure is changing, the stronger the winds are going to be. Okay, now over here on this side, you can see that the lines are farther apart. Okay, so I can promise you that there's not going to be anywhere near as much wind as over on this side. This is going to be calmer weather, far apart isobars, low or gentle pressure gradient, and so that's what takes place. But winds blow from the high to the low. Make sure you know that. Okay, moving on. Alright, so the Earth rotates at the rate of 15 degrees per hour. Okay, we've talked about that quite a few times. It rotates 360 degrees in 24 hours, so that's 15 degrees per hour. Okay, now, the Earth is rotating counterclockwise from the west to the east. Okay, like I showed you here in this diagram right here. It's going around like this, spinning around in a circle like this. And I know it's tough to see it in a two-dimensional picture here. But anyways, so the Earth is actually, the surface at the equator, the surface of the equator is actually moving over 1,000 miles an hour. Okay, so it is very quick, a lot quicker than we realize. We don't feel that because we're stuck in the Earth's atmosphere. Okay, and so we don't feel that we're moving that fast, but we are. Okay, now, Earth's rotation causes the wind to curve or deflect. Whenever they don't go straight, if they curve, that's a deflection. All right? Now, this is called the Coriolis effect. In the northern hemisphere, things curve to the right. In the southern hemisphere, the winds curve to the left. Okay? Now, I want you to pay attention to this very quickly, and I really want you guys to look at page 14 in the reference table. Okay, your ESRT, page 14, has a planetary wind map that shows you between what latitudes how the wind is blowing, and it blows in different directions. But always in the northern hemisphere it's curving to the right, and in the southern hemisphere it's always curving to the left. Okay, but anyways, yep, this is pretty obvious. If it goes from the equator here and goes northward, all right, it's curving to the right. You can see that bend to the right. Now, on the southern hemisphere here, well, if you look at that, it looks like it's going to the right. No, because what you have to do is you have to get yourself in line with this. And I'm actually going to take this and turn it upside down here so that you can visualize it this way. You see how it turns right here? How it's going in this direction. Now I'm in the southern hemisphere, but I turn the Earth upside down so that you guys can see this. Okay? But only see how that is actually bending to the left? You have to get in the direction. Follow the path that it would be going. Okay? So, back onto this picture here really quick. Okay, bends to the right in the northern hemisphere, bends to the left, again, get in the direction that this is traveling, and it bends to the left in the southern hemisphere. Okay? Like I said, on that last map, that map of the world, if you look at page 14, you'll be able to see that a little more detail. We'll talk about that in class also. All right. Now, what I did is I put this little light dotted line here to kind of separate these two so that you could see separately what a high pressure does and what a low pressure does. Okay, and I tried to put them different colors so that you could kind of see. And I tried to show some of the winds blowing from the high and into the low and how they work. Okay, winds blow out of the high pressure. Okay, and because of the Coriolis effect, because of the spin of the Earth, okay, they curve to the right. Okay, we're in the northern hemisphere. Actually, in the southern hemisphere, high pressure spins the opposite way. Okay, because in the southern hemisphere, the winds are blowing to the left, so they actually would be curving and going the opposite way. That's not typically a question that you need to understand, but I want you to realize that it is a reality. Okay, now, so you've got the winds coming out of the high pressure, bending to the right. Which way is that going to make this look like it's spinning? It's going to spin around clockwise. Okay, because if the winds are coming out and bending out to the right like that, it's going to make the high pressure system spin clockwise. That's why I wrote down here, clockwise and away from the H, away from the high pressure. Now, the winds are blowing out of the high pressure and into the low pressure. Okay, and as they blow into the low pressure, they actually bend. And yes, I know they look like they're curving to the left a little bit, but only if you could look at each individual city. They actually are still bending to the right, but they have to bend into the low pressure because the low pressure is almost like a vacuum cleaner where it's just kind of sucking in everything, okay? And so it kind of pulls it in towards the center of it, right? But that's going to make this spin counterclockwise, okay? Now, counterclockwise and in towards the low pressure, okay? So, winds blow out of the high and into the low. Notice that when it comes into the low, everything mixes up, okay? And you get a lot of weird weather when you start bringing a lot of stuff into, a lot of air into the low pressure region right there. All right, now in low pressure, these are some of the things that I just talked about. You get winds that converge, come together, okay? Now these winds are spinning counterclockwise or cyclonic. We call it cyclonic, like a cyclone, like a big storm. They call them cyclones out in the Pacific Ocean. But anyways, that's a counterclockwise spin. That's what low pressure does, just like that last picture. If you need to look at the last picture, go ahead. Take a look at it right now. But that's a counterclockwise spin. We also call it cyclonic. Now the weather associated with low pressure is warm and wet. Low pressure is warm and wet weather, okay? If you can think about the last time that it was raining, that was low pressure. We've talked about it in class. Now, what's taking place? This is a convection cell, just like the convection cell in the water that I showed you, but this is trying to show you in the air because this is the land, okay? So the air comes into the low pressure and it rises up. Now as it rises up, it cools down. It cools down to the dew point, creates clouds, and if you get enough moisture pumping up into here, you get a lot of precipitation, okay? Now, this is all because warm air rises. Warm air is rising, causing it to cool, condense, and create these clouds. Now this is a surface view, looking at it from the side on the land, looking straight across the land. We don't see what's happening up here because we don't have our weather instruments typically up there in the air. And we're not standing up there. This is where planes are flying. This is, you know, so we don't know what it's doing up here. When we get our weather readings, we're finding out what it's doing down here on the surface of the land. Okay? But see how all this air comes into the low pressure system? That's what's taking place, just like that last map. And when you look at it from above, this is what it looks like. You have, just for example, I threw in some millibar pressure readings, 990, 980, 970. So it's getting lower as you go in. Okay, so that's the center of the low pressure system. Now I can tell you right now, the winds would be coming in and curving into the low pressure right here. They'd be curving into it. Okay? Into the low. Okay? Now, this is a map view from viewed from above. So, if you look here, I wrote down that low pressure is where clouds form. Warm air rises. As it rises, it cools to the dew point and condenses to form clouds and precipitation. You need to know that because that is cloud formation. That is how you get a cloud. So if there's a question that says, how do clouds form? Right there is exactly how clouds form. All right, high pressure. High pressure is when the winds are diverging, okay? They're going away from each other, separating. That's diverging, dividing, okay? You get a clockwise or anticyclonic because it's not cyclonic. Cyclonic is a low pressure, so this is anti or not cyclonic, so it's just the opposite. So we're going to be spinning clockwise in this. Now, the weather associated with high pressure is cool and dry air. Because what's happening, right here is the center of the high pressure. This is a convection cell. I drew it opposite, okay? Last time when I just showed you in the other diagram, you saw the air rising here. So I just moved over one of these cells to show you what it looks like with the high pressure, okay? Now the high pressure is you have the air sinking. Well, what air sinks? Cool, dry air. Well, that's why we have cool, dry air is more dense. That's why it sinks, creating high pressure. If you have a lot of cool air that's dry, and that provides a lot of weight on top of your head. That's why the air pressure is high, okay? And creating high pressure, like I said there. Now, over here, that's the surface view. That's looking at it from the side. This is looking at it from above, like a weather map, okay? So, I threw in some millibar pressure readings. So we have 1,000 millibars, 1,010, 1,020. So the higher pressure, it's getting higher as you go in, okay? Now the winds would be blowing from the high pressure into the low pressure, so they'd be blowing out, curving to the right. Okay? So, big things that you need to remember with pressure systems. Low pressure is warm, wet air. High pressure is cool and dry air. Low pressure spins counterclockwise, high pressure spins clockwise. Okay? Diverging winds at high pressure, converging winds at low pressure, coming together, dividing apart. That's what those two mean. Okay? So, hopefully this clarifies, and the whole reason that the winds don't go straight, okay, the winds don't go straight, and we're going to talk about this more in class, but the reason that the winds don't go straight is all because of the spin of the earth. Because the earth spins, as the wind goes across the surface, it makes it look like it bends to the right in the northern hemisphere and to the left if you're in the southern hemisphere.